So you can create indexes either through the GUI using Management Studio or through code. I'm going to show you some code first, then we'll walk through the GUI. So in the OBX Kites database, in the create script, there are a few indexes. Here's one. It's for the contact table, and as the primary key, which is contact ID, is being declared, and it's being set up as a primary key, by default the primary key will create a clustered index. But here I've defined this as a non-clustered index, and then afterwards use the DDL command to create a clustered index, calling the name of the index ixcontact on dbo contact, which is the table, and then soundex code. And what this does is it optimizes searching on this table so that people with the same sounding last names using the soundex code are grouped together. Good idea or not? Maybe, maybe not. What'll determine if it's a good idea is how it will work with the queries. Just like an index in the back of the book, it depends upon what you're searching for. If the index is a good shortcut to make most of the questions find answers quickly, then it's a good index. The nice thing about indexes is that they don't change the logical outcome of any query, so you should be able to feel free to try out one set of indexes, then try out another set of indexes. So let me close this script and let's look at Object Explorer. I'm going to drill into the AdventureWorks database, and under a table is where we will see the indexes for that table. The clustered index is the one with the parentheses around there, indicating that they are ordered. Let's look at that one first. The name is primary key, or PK contact ID. If we look at properties, we see it's clustered, it's unique, a unique constraint, unique index, and a primary key all set that unique value. And there's only one key column. The key columns are those columns that are actually sorted. There's a couple options here that are worth talking about. The first one has to do with statistics. SQL Server will automatically build statistics for any index, and it uses these statistics to keep track of how much data is there for each entry in the index. For example, for the contact table, if a third of the people live in New York City, then there will be an entry in statistics that says New York City and has, I don't know, maybe 33,000 as a number there. And if there's only one entry from Payton, Colorado, it'll have only one. And then SQL Server will use these statistics to determine whether or not the index is useful to solve a particular query. So if we want to find everyone from New York City, it doesn't want to have to do 33,000 index seeks, looking from the index into the data page 33,000 times. It'll be faster just to scan in the entire book. But if it's looking for that one person from Payton, Colorado, then it knows, aha, this is a perfect time to use this index and to use an index seek. So statistics are vitally important, and if the statistics are not up to date, SQL Server might select an inappropriate index. So I recommend keeping automatically recompute indexes turned on for all but the most extreme cases where you're doing lots of manual ETL, or extract, transform, load, to populate and to remove items from the database. And you don't want the overhead of recomputing statistics during that process, but you want to build them automatically at the end. Let's also talk about the fill factor. For each 8K data page, SQL Server will fill it up to a certain percentage and leave a little bit of extra space there. And this can affect performance in a couple of ways. First of all, let's say you leave 10% of free space, setting the fill factor to only 90%. That'll make the number of data pages used for that table that much larger. So SQL Server will have to read in more data pages, that's more I/O, and it can slow it down. However, if you set the fill factor too high, either inserting new rows or adding additional data to a text column or something, and that data page then becomes too full, SQL Server will have to do what is called a page split. And it takes that single page and writes it back out as two pages that are both half full. There's two problems with that. First, we have empty space in our data pages, which again stretches out the amount of pages used by the table. And secondly, we're now fragmented because that new data page is stuck someplace else where SQL Server finds some free space in the database. So we want to avoid page splits, but we also don't want the fill factor to be set too low. A key item in thinking about the fill factor is going to be the data type used for the clustered index. If the data type is an integer with an identity column so it automatically increments, then every new page will be at the end of the data set, and you're not going to have problems with rows being inserted into the middle of a page. However, if the clustered index is based upon a primary key that's a natural key, then chances are you will have lots of inserts into the middle of a data page. Say your natural key is last name. Well, you're not going to be able to force everyone who's signing up to join the organization to arrive in alphabetical order. They're going to come in some kind of random order, and you'll have data being inserted in the middle of pages continuously. Or let's say the clustered index is a GUID. So GUIDs will also cause lots of page splits. There is a workaround for the GUID/page split problem in SQL Server 2005, and that is that when you create your primary key, you can give it a default of, instead of new ID, new sequential ID, and then every GUID that's generated is guaranteed to be larger than the highest GUID value currently in that table. So that's pretty cool. All this has to do with page fill and optimizing how much data is on each page. By default, this set fill factor is set to 100, which is pretty full, to be honest. And I would normally change this back to 95 or 93 or something, just so I have a little bit of room so I can have some updates to the data. Now, fill factor is only for the leaf level of the index. If you also want to have some fill factor or some free space for the intermediate nodes in the B tree, then you want to select this pad index option. The last thing I want to say about fill factor is that SQL Server does not automatically maintain a fill factor. So let's say you set it to 85 because you're expecting data to be added to the rows as data is updated. Over time, this fill factor will get out of whack and the table will become fragmented, and if you want to get everything back to defragmented with the perfect fill factor, then you have to do a rebuild of the index. And that's normally a DBA process. They set up a maintenance plan, and the indexes are automatically rebuilt, say every week or sometimes once a night or something like that. But just so you know, fill factor is not a set it once and forget it. It's a set it once and then rebuild it periodically. We're going to come back to included columns in a little bit when it makes more sense. The storage page allows you to define where on the disks this index is actually located. So if you have a lot of different disk subsystems, you can place your data on one disk and index on another disk and help spread out the number of spindles that a query will use. Fragmentation gives you a nice report on the percentage of fragmentation, which we were talking about, and the average amount of page fullness, which is that fill factor we were talking about a minute ago.